First, we're going to calibrate the pH meter by using buffer 4 and 7. We start off by removing the pH probe from its container and rinsing it off with distilled water. Then we place it in buffer 4. We go back to the pH meter and under Files we click Sensor, and it will lead us to a new page where we press Calibrate Now. Until it reaches a stable voltage, we enter the pH of 4. Then we rinse off the pH probe before placing it in buffer 7, and we place the pH probe in buffer 7 until it reaches a stable voltage. Then we enter pH 7. Then we rinse it off. A thing to keep in mind is in between every use, you have to rinse off the pH probe to accurately read the pH substance.
Strong acids fully ionize when they're placed in water. This means that they release more protons in the solution, so the solution will be more concentrated with a lower pH. Weak acids, on the other hand, don't fully dissociate. This means that they release less hydrogen protons in the solution, so the pH will be a little higher compared to the strong acid. The reaction between a weak acid and water is reversible because the weak acid only partially dissociates.
A buffer is an aqueous solution that has the ability to avoid major pH changes in the presence of additional acid or base. The buffer avoids this pH change because the conjugate base and conjugate acid are in the solution at the same time during equilibrium. This causes the buffer to neutralize any acid or base that is added and prevents the pH from changing significantly. On the right, we have an example. If a strong acid is added to this buffer, the ammonia, NH3, will interact with the hydronium from the strong acid and create ammonium, the NH4+, and water. NH4+ is already in the acid since it's the conjugate acid, so this will not affect the pH. If a strong base is added, the OH from the base will interact with the ammonium ions to make ammonia, NH3, which is already in the buffer since it's the base. So this will not affect the pH.